After t seconds, the distance x meters from a fixed origin of a particle moving in a straight line is expressed as a function of time. So a function of time. So it means that x is the distance in terms of time where t is greater than 0. What's a little bit confusing is the following. If I have this, it means my graph looks like something like this. My variable is t and this is x. So I think that's why some people find this very confusing, because it's x in terms of t. Like we usually have y in terms of x, we have x in terms of t. Okay, they ask us what is dx dt. Now, please, if you do battle with your basic rules, then take this and use the distributive law and get rid of your bracket first. If you know what you're doing, we can do the following. I'm going to just quickly say that's a half t minus 4 squared plus 3. Okay, and we just say t cannot be greater or equal than 0. Sorry, t is greater, not cannot, is greater or equal to 0. So what I have is dx dt, so that's the derivative. And what I have is the chain rule, because I have a function to a function. If you can't do it, multiply this out. T times t is t squared, minus 4t minus 4t is minus 8t, minus 4 times minus 4 is plus 16. Multiply everything, get a linear quadratic equation, and then differentiate. If you know what you're doing, this is what I'm going to do. The half stays there. So this half is this half. Now I have a bracket. Okay, and if I have a bracket, this 2 comes to the front. So something to the power 2, outside first, the 2 goes to the front. So it's times 2, and the bracket stays like it is, and the power becomes 1 less, which means t minus 4 to the power 1. I then multiply with the derivative of the inside. So remember, outside, inside, something to the power 2, the 2 comes to the front, that 2 becomes a 1, and now I have to multiply by the derivative of t minus 4. The derivative of t is 1, the derivative of minus 4 is 0, is nothing, so it's just times 1. The derivative of plus 3, that's a constant value, so that just falls away. This 2 cancels with that 2, so dx dt is t minus 4. So that's your first answer, t minus 4. This is the rate of change, that's our x change in terms of t. When I ask this in the next question, what is the instantaneous rate of change of the distance after 6 seconds? Interpret its sign in relation to the particle's travel. So what I'm going to do is the following. This dx dt is the rate of change. It's the instantaneous rate of change, which means what I want to know is when dx dt, what is dx dt when time equals 6. Okay, so I'm going to find what is the derivative of the function, or I'm going to say the derivative of x at when the time is 6 seconds. That will give me 6 minus 4, and that equals 2. So it's positive 2. That positive 2 is how does x change in terms of time. In other words, x is in meters and time is in seconds, so it's 2 meters per second. So at 6 seconds, the particle is moving away from the particle, from the origin at 2 meters per second. The speed is, I can't say it's moving away, or you can say it is changing at 2 meters per second. Let's look at number at C. When you look at number C, let's say calculate the average rate of change, the distance over the first 6 seconds of travel. Coming again to the average. The average, if we have a function like that, the average is between 2 points, so you just need to know what's the first and the second, the first and the last value. So I need to find out what is x. The first means at 0, So when x is 0, I'm going to put 0 in here in the place of time. So it means a half 0 minus 4 square plus 3. And this answer of mine will be 5. Minus 4 square is 16. 16 times half is 8. 8 plus 3 is 11. Okay, and what is x at 6? X at 6 equals a half. Taking it back to my original equation, it's a half 6 minus 4 squared plus 3. 6 minus 4 is 2. 2 squared is 4. 4 times a half is 2. 2 plus 3 is 5. So what's the average? I'm going to say the average rate. The average rate equals y2 minus y1 over x2 minus x1. Okay, that gives us, remember, anyone is anyone. So when y is 5, and that is 11, then x2 is 6, take away x1, which is 0. That will give us 11, 5 take away 11 is negative 6. This is 6 take away 0 is 6. So my answer is negative 1. And my answer will be meters per second because it's again rate of change. Let me just put values. This is A, this was B, this was C. For D, at what time and at what distance from the origin is the speed of the particle 4.5 meters per second? Now remember, speed meters per second means that is when the instantaneous rate. So that is when dx dt equals 4.5. Now what is dx dt? I know dx dt is t minus 4. So at t minus 4, when that equals 4.5, what is t? T equals minus 4 goes over, it becomes plus 4. So that is 8.5. Now we know what is the time. What about the distance? To put the distance, I'm going to take this time and I'm going to put it back into my original equation. I'm going to say, well, x equals a half. When time is 8.5, take away 4 squared plus 3. And if I do that, my answer works out to be 13.125, and that is now in meters. And that is for question number D.